And here we go. The main thing you're learning to do today is called an inverse. But to be able to understand what an inverse even is, inverse of a matrix, I just want to just do a regular inverse that you would be able to relate to. If I said 2y equals 16, you'd all know I could divide by 2. But see, with matrices, you can't divide. You have learned how to add them, subtract them, and multiply them, but there's no such thing as dividing matrices. So you can't, when you have a matrix, you can't divide by it. So you have to know that we could solve this without dividing. Couldn't we multiply by something? What would we multiply by? Come on, what would we multiply by? 1/2. Good. Why would we do that? Because these two are called inverses. That's why we need to learn inverses of matrices, because you can't divide by matrices. So you got to learn how to get an inverse. Because see, when you multiply two things like this, it turns into 1. And then it's 1y equals 8. And 1y is really just y. But this brings up a whole bunch of things about matrices. When you have a matrix and you have to find its inverse, it's complicated. Thankfully, the calculator can do it, but we will test you by putting a variable into the problem so that you can't just trust that you know how to do it with a calculator and I'm good. No, you have to be able to do it both ways, by hand and also with the calculator. All right, so let's go back and review just a little something on the calculator. First thing I want you to do, second key, plus key, 7, 1, 2. And it does two things. Not only gets you out of weird modes, it wipes the matrices you already put in there, which they're kind of a pain. If you have matrices in there, you got to override each number. So might as well just wipe your calculator back to factory new with second plus 7, 1, 2. You got that done? Where's your calculator card? Oh, good. All right, so if once you got it wiped, then I want you to go in and find matrix A, edit it, and make a nice, clean, simple 1, 2, 3, 4 is our matrix we're going to put in for matrix A. Just put that in the matrix A. Now, I want to remind you how to multiply two matrices. So if this is going to be matrix A, which we usually put a little bracket around it, don't have to. If you use a capital A, you can tell it's not a variable. I don't know if you've ever thought of that before. Variables are supposed to be lowercase. So when you make a capital A, it's kind of indicating it's not a normal variable. So we can just call it capital A for this matrix. All right, if we're going to multiply a couple matrices, you got to have two of them. So I'm going to give you a matrix B, and I want you to tell me, would, don't type it in yet, just I'm asking a question. Would this matrix be able to multiply by this matrix? Are you sure? Because this is a 2 by 2, and what's this one? A 2 by 3. If you check that already in your head, that's magnificent. And then you'd know that these two matrices would be able to multiply together. Cool. And the answer would be a 2 by 3. Okay, let's do it with the calculator. Take a second, get the A matrix, get the B matrix. You're editing them first. And at the end, you gotta go second quit before you try to make it go A times B equals. Now, somebody's going to get stuck in there. I'm not going to make you slide your desk next to the kid next to you this time. But that's your first call for help. If like, whoa, I did something wrong. Have them look at it and see if they can figure out what they did to make it work. You know, like what did you do wrong, okay? All right, so please compare your answer with the kid sitting next to you. Could you read it to me?
10, 3, 17.
10, 3, 17, and then
22, 7, 37.
you guys verify that this is the correct answer? Is that what you guys got? Okay, awesome. So that's how to multiply matrices with a calc, and I'm not going to review why do we do it by hand. That was a long process, taught it all yesterday, except for just one of them. Just to make sure you haven't completely forgot this. How would we have gotten the 10? Well, that's row 1 and column 1, and we would have gone 2 times 2 is 4. 2 times 1 is 2. 4 times 2 is 8. 8 plus the 2 makes 10. So that's how I would have got that 10. Remember that part? Because this was row 1, column 1, we use this row and this column. Okay, good. But the calculator's way faster. It's really nice to be able to do that. Okay, now, next thing I want you to do is if I wanted to get the inverse of A, the A matrix, you haven't changed the A matrix by multiplying it by something. A matrix is still the A matrix. So if I wanted the inverse of the A matrix, the first thing we'd have to understand is what is it even going to do? If I knew the inverse of 1, 2, 3, 4, whatever that mystery matrix is, here's what it would do. When you multiplied these two together, and this is important, doesn't the order of the matrix matter? Like if I have, this is A, that's a matrix, we said it was A. A times A to the negative 1 is going to come out different than A to the negative 1 in front of it. Whoa. Remember, multiply in regular multiply, 3 times 7 is the same as 7 times 3. You can reverse it, but not in matrix world. So you always do the inverse first. Okay, so the inverse that I put on the right of this, no, it wouldn't actually be there. The inverse that you calculator can calculate for you would go right here, and those 4 numbers, when multiplied by this, give you 1. But do you think it actually comes out to a single 1? Is that what 1 is in matrix world? Oh my gosh, it's getting more complicated. No, it can't just come out to 1. Not a single 1. Well then, logically, you would probably think it would come out to 1, 1, 1, 1. Like this. But the way I'm saying it, you could probably tell it doesn't come out to that either. So what the heck is 1 in matrix world? Go to the next. This is it's telling you that, well, if you multiplied these two matrices together, you'd think that this is the 1 matrix, called the identity matrix. That's what the number 1 is. It's called, 1 is called the identity. So if I multiply this times 1, it does not come out to the same thing as it was. It doesn't come back as 5, negative 4, 1, 8. That's not what you get. You get 4 completely different numbers. Trust me, we're not going to multiply this out. I'm going to save that 1 minute. But when you multiply this out, I'll just do the first part. You would have gone, let's row 1, column 1, right? Row 1, column 1. And watch, 5 times 1 is 5. 4, negative 4 times 1 is negative 4. So 5 plus negative 4 is 1. It's not 5. So again, I'm not getting back the original thing. This is not acting like a 1. At the page, next page of the notes. This is what 1 is in matrix world. If it's a square matrix that's 2 by 2, it's 1, 0, 0, 1. If it's a 3 by 3, it's 1, 0, 0, 0, 1, 0, 0, 0, 1. See how the 1 goes in a stripe down from left to right? Same thing here. That's 1 in matrix world. So if you want the original matrix that you have to come back again, you use times by this. That's called the identity. That's what 1 is. I don't want to do the whole thing to save time, but I want you to do just this first number and prove to yourself that you get 5 back again. Use row 1, column 1. So Jaron, if you're going to multiply to get this, it's row 1, column 1. Tell me what to do. Yep. And so 5 times 1 makes 5. And then the other one's getting multiplied by 0. See what they're doing? They're making you always multiply the other thing by 0. So that's why you get 5 back again. And if you do this, you're going to get the original back. You're going to get 5, negative 4, 1, and 8. So that is like 1. All right, that's one little breakthrough. You've learned one of the 5 things I got to teach you today. All right, here's the next one. That ABCD, we're using letters, ABCD, can be turned into its inverse. That's what a little negative 1 power means, is that we're turning it into its inverse by taking 1 over all that, which is A times D minus B times C, and then multiplying it by D negative B. And if you just look at those, it's so confusing, but what it really is these two got flip-flopped. You know how A and D used to be in the opposite spots? And this B and this C stayed in the same spot, but they became the opposite. So I like to call this part flip-flop, op-op. Flip-flop, the left, upper left and the lower right. These two get flip-flopped, and these two just become the opposite of what they were. All right, so we need to do one to actually understand this. So we're going to take our matrix that's 1, 2, 3, 4, what I consider the simplest 2x2 matrix you can make. 1, 2, 3, 4. And we're going to walk through the process. You'll have to be able to do this on the test. So you're going to want to take good notes. So make this one your one good example of how to make an inverse. The answer is not 1, 0, 0, 1. Remember, that is not an inverse. That's what you get when you multiply 2 inverses together. It comes out to this, which is like 1. All right, so we're trying to find the inverse of 1, 2, 3, 4. So the first thing you do is, if you're really good at just following directions, you can just do this. 1 over, and then AD, which is this times this, which is 4, times 1 is 4, minus this times this, 3 times 2 is 6, times flip-flop, op-op. Alex, what am I talking about with flip-flop?
It's like A and
Yep.
B. They're flip-flop and C and D are opposite.
So in this case, what numbers get flip-flopped for my A matrix? Remember, this is called A.
Yeah, 1 and 4.
Yeah, 1 and 4. So 4 goes here, 1 goes here. And an op-op means negative 2 and negative 3. There you go. Now, if you just simplify this all the way down, you've got the answer. A small child can do 4 minus 6. I should be careful because I made 2 mistakes in the first hour here. So, you probably can do 4 minus 6. All right, so we got 1 over negative 2 times 4, negative 2, negative 3, 1. And now if I actually multiply those out, it's really taking half of the number and then making it the opposite. So what's the half of the 4 would be 2, but then make it opposite, negative 2. Half of this, and then make it the opposite of what it was. Half of 2 is 1, and then make it the opposite, it'd be positive 1. And then half of that, that's 3 over 2. Or you could have said 1.5. Half of 3 is 1.5. And then there is two negatives times each other, so it's going to be positive that. And then half of 1 is 1/2. And then make it negative, because there was a negative right there. There it is. I think if we just do another one right now, you might be able to do it without any help and be able to, have this down. But just make sure you know what you just did. You just found the inverse of A. Now let's make sure you understand why you would even care. What would you even need the inverse for? Here's a typical question. Just watch. Don't write this down. It'll just take too long to write down. Say I have this, and it's times by x, y, and I know it comes out to 10, 10, 10, 10. That got confusing. Let me move that 0 over. There we go. And then I got to figure out, how do I solve this? If I could just get rid of this, i.e. multiply by its inverse, then this could go away. Really, it's going to turn into 1, 0, 0, 1, which is like 1. Then I'd have it solved, and x would be alone, and I'd have an answer like x, y comes out to some matrix. That's my final answer. And I'd figure out, oh, x, y is really like 6, 10, and I just solved the system. All right, so if I'm trying to solve for x, y, and I had this problem, I'd need the inverse of this. So I'd like to do that one. 2, 4, 7, 9. Can you find the inverse of that, please? I'll give you a hint. You're going to want to 1 over the determinant. This part here, where you go this times this, is how you start it. That's called the determinant down there. DET is the abbreviation for it. It's got a special name. It's called the determinant. So you go 2 times 9. Would you please talk to the kid next to you about how to finish that? Just the determinant, just the bottom of that fraction. Josh, diagonal here. She's working on the test. All right, good. All right, so what do you do? 2 times 9, and then what? Minus 7 times 4. And it won't ever matter if it's 4 times 7 or 7 times 4. That won't matter. Okay. So this would be 1 over 18 minus 28. So did you get 1 over negative 10? Raise your hand if you had that right. Nice. Now you just got to remember the flip-flop op-op thing. Carlos, instead of the 2 and the 9 being where they are, it becomes 9 and 2. And then what's the rest of it? Negative 4 and negative 7. Flip-flop op-op. Now, that's not a math word, but it's just a way to remember something, kind of like PEMDAS. PEMDAS is not a math word. It's just a way to remember that order of the stuff, right? There's like little jingles you memorize to try to remember which months have 31 days and which ones don't. Again, that's not math. It's just like a way to remember it. So flip-flop op-op is definitely not a math word, but it'll help you remember it. It's the way I remember it. My final answer then is to just multiply everything by 1/10, which really means just divide it by 10. But don't forget the negative. So this becomes negative 9/10. This one becomes positive 4/10, which, yes, it reduces, but I want to not do that right now. And this will be positive 7/10. Got to make sure I don't forget to cancel the negatives. Half the time that was my mistakes last hour. And this will become negative 2/10. But again, I know they reduce. Cool. We did it all by hand. Do you get that there'd probably be a faster way on the calculator? For sure. We're going to do the calculator way in just a second. But this is reminding you that the first part was called the determinant. The math word for that is determinant. The abbreviation is DET. And the way you find that on a calculator is there is a thing called DET. Okay, and I'll show you where it is on the calculator in a second. But if I had to do it, I would just go that times that. So 8 times -1, and it doesn't matter what order. Minus that times that. And I'm just going to do it. 6 times 3 is 18, and it's -18. So this would be -8. Minus negative means plus 18, so this one would be 10. That's the determinant. Now, there is a special determinant. Man, there's so many little things today. This is why the lesson takes so long. There's a special determinant. If it ever comes out to 0, that's special because, do you remember in that little formula of 1 over the determinant times flip, flop, op, op? Remember that little formula where you take 1 over that thing? What if it was 1 over 0? It doesn't exist then. So, if the determinant ever comes out to 0, I mean, if you want to just finish the problem, you can, but then you'll get here and you'll realize, oh crap, that's right. 1 divided by 0 makes the whole thing not work. That means there are some matrices that don't have determinants and therefore don't have inverses. I mean, the determinant is 0, but that means that the inverse thing where you do flip, flop, op, op can't work. So you can't get inverses sometimes. This is where you get a little bit more like pre-calc, where the right answer sometimes is that there is no answer. That happens a lot in pre-calc, you'll see. Not like all the time, but a frequent answer, like at least once a week, the answer comes out that there is no solution. All right, on to this page. So here's the big picture of taking A, B, C, D and doing the inverse to it. You take 1 over the determinant, you flip-flop the A and the D, you make the B and the C opposites. That's what that's saying. That's how to make an inverse. And remember, that part is called the determinant. Okay? All right. If you understood me, you should be able to take 2, 2, 2, 4 and find its inverse with just your brain without any help. I'm going to be quiet for a second while you try this one. Just to make sure you get started right, you should have done 1 over the determinant, which was 2 times 4 minus 2 times 2. So that would simplify down to 1 over 8 minus 4, which would be 1 over 4. And then all I got to do is the flip-flop op-op. 2, 4 switches around to 4, 2. Op-op, -2, -2. And would you please compare your final answer to the kid next to you? Have you guys, 2 guys compared yet?
I'm still working.
Okay. All right. Aiden in the corner. Final answer.
-1 over 2,
You got it. Good job. Okay, now what we're going to do is find the inverse of this using a calculator. So go in and make your matrix A be 2, 2, 2, 4. Get your matrix A changed over to 2, 2, 2, 4. And then all you got to do is quit, which I know feels weird. And on your blank screen, pull up the A matrix, which it'll be in a bracket, and then put it to the -1 power, which is the key that's right next to the matrix zone. So it's really, really close to matrices. And it's not an accident. It's on purpose because you do inverses of matrices all the time. So they on purpose put it right above that key, which makes sense. And you'll know you're right because we already know the answer. It should be this. Now I'm curious, did it default to decimals? Okay, now let me show you how to change it to fractions. And you might think, well, why? Decimals are fine. Because sometimes the answers are really long decimals and you won't be able to read all of them. So you have to change them to fractions to be able to read it. So you want it to look like this, like fractions, you do math key and then hit enter twice. Math, enter, enter. That converts it to fractions. I want you to then show the kid next to you, and if they got lost, help them see how to make it fractions. Raise your hand if you had any. How about this? If you got it to fractions, raise your hand. All right, good. All right, cool. So, I love seeing some help. Keep helping. That's awesome. All right, so here's the plan. You're going to be given problems like this on your test. You're going to be smart enough to know, oh, I got to get rid of this so that I can solve. Oh, yeah, I'm going to call this matrix A, and then I'm going to multiply by the inverse of A, and I remember that you have to do it on the left. This is not matrix A, this is matrix B, but if I multiply by inverse of A on both sides, these two will cancel each other out and turn into what's like 1 in matrix world. And so the answer is really over here. And that means to solve the hardest problems on your test, you'll just need to know that this is matrix A and this is matrix B. And the answer is going to be inverse A times B, which will all go really fast on a calculator. I know we're not there yet. Don't worry. That's not in the homework for today. All right. So I'm just going to review some of the key stuff for the kids at home. May not have caught this. If you made a 3x3 matrix and called it A, to find its determinant, you would go DET of it. Now, we're going to do this one from here. On this side, please get to this slide. And I want you to be able to see how to do the determinant of a 3x3. Because you can't just go this times this minus this times this. That won't work. So you have to do some of these on a calculator. That's why we allow the calculator on this test. So for right now, you're just making a 3x3 matrix. And we're going to make sure you know how to do determinants. Det. Notice it's in the middle menu of the matrix menu. And it'll tell you the determinant. It should come out to 1146. If you can get that to come out 1146, then you get how to do determinants of any matrix. The calculator can do it. And the only determinant you gotta watch out for is 0. Because if you take 1 divided by 0 in that other formula, it'll kill and the inverse. So determinants of 0 are special. Want me to come back there? Okay. Let me make sure I'm paused for a second. So, we're back. You got the determinant. And what does it do? It's 1 over that number times flip-flop op-op. That will give you the answer. But now that we're doing stuff with the calculator, wouldn't it be so much easier to find the inverse of this by just putting A out there, putting it to the -1, getting this really weird decimal answer, and then changing it to fractions with math enter enter. Prove to me you can do that. You've already got the A matrix entered. It's this matrix right here. Then you just got to put it to the -1. Then you got to just change it to fractions, and you'll be able to show me this screen. There's no way you're going to fake that. You either can get 58 over 573 to come up like that, or not. So again, you're doing this page. All you're really doing is the inverse of A, except with a calc. And by the way, the button you use to get the power of -1, it's x to the -1. Just hit that button, and it puts A to the -1. Hit enter. You should get the decimals, which you can then math enter enter over to fractions. All right, I'm going to walk around and see if you got it. You got it. You got it. You got A in there yet or not? Now change that to a 3 by 3. Got it. Yes. In a second, check it behind you. Yep. Got it. What? Sometimes the question on the test is just, what's the determinant? So the determinant is the 1 over that, you know how there's that equation, the determinant's that bottom part. So no, you can't do it in your head if they're 3 by 3. So the determinant is used, you have to use the calculator to get the determinant on the test because it's a 3 by 3 matrix. Yes. Okay, cool. Everybody can do inverses. Yay. And you know how to change them to fractions. All of that's going to come up on the test. There's a reason that this test averages an A. It's not incredibly hard. But if you go into this with some things like, I don't know how to do the calculator, well, you're toast. So it'd be really smart to come in and get some help before we take this test. Remember, my help days are Mondays and Thursdays. So today I had some kids in, and I hope I see some more on Monday. All right, so we're not going to continue this. We're going to go right to the, I will get the final punchline. How do we know if two matrices are inverses? If you multiply this times this, it's supposed to equal 1. But do you remember what 1 is? What's the answer to these two? This times that, A times B. If they were really inverses, it should equal 1, 0, 0, 1. Raise your hand if you knew that. Cool. All right. Then it's a worksheet, and we are doing the evens, aka do problems 2, 4, 6, 8. Do the evens. And that's all I got for you for the video for today.